Hello students, I am Mohammad Rizwan. Today we are going to learn the new topic direct and inverse proportions. Children, we come across many situations in day-to-day life where we see a change in one quantity brings a change in the other quantity. Let us learn more about the concept of variation that helps us to handle situations efficiently. Now, let us consider such situations which we come across in everyday life. We consider the task of cleaning a school. When a great number of students are involved, the time taken to clean will be less. When the number of students is more, the work done will also be more. In the first case, the number of students is compared with the time taken, and in the second case, the number of students is compared with the amount of work. The quantities taken for comparison decide the type of variation. Let us see the variation in two situations. First, Diya prepares vegetable soup for a family of 4 members. She uses 2 cups of vegetables, 600 ml of water, 1 teaspoon of salt and half teaspoon of pepper. Suddenly, her aunt and uncle join them. What would be the change in quantities of the ingredients to prepare soup for all the 6 members? In the second situation, in a military camp, there are 200 soldiers. Grocery for them is available for 40 days. If 50 more soldiers join them, how long will these groceries last? In the above situations, a change in one quantity results in the corresponding change in another quantity. That is, in situation 1, the more the number of members, the more will be the number of items. In situation 2, the more soldiers in the group, the grocery needed will be more, and so it will last for less number of days. In these situations, when one quantity varies, that brings a change in another quantity in two ways, that is, both the quantities increase or decrease. An increase in one quantity causes a decrease in the other quantity or vice versa. They are said to be in proportion if such quantities vary in constant ratio. Two different variations give rise to two types of proportion, which will be discussed now. After completion of this lesson, you will be able to know learning outcomes. To understand the concept of direct and inverse proportion. To differentiate direct proportion and inverse proportion. To solve application problems using direct and inverse proportions. Keywords from this lesson: ratio, proportion, direct and inverse, number, increase and decrease. Direct proportion. For example, if the cost of a shirt is rupees 500, then the price of 3 shirts will be rupees 1500. The price of the shirts increases as the number of shirts increases. Proceeding the same way, we can find the cost of any number of such shirts. When observing the above situation, two quantities, namely the number of shirts and their prices, are related to each other. When the number of shirts increases, the price also increases in such a way that the ratio remains constant. Let us denote the number of shirts as X and the price of shirts as Y, rupees. Now observe the following table. From the table, we can observe that when the values of X increase, the corresponding values of Y also increase in such a way that the ratio X by Y in each case has the same value, which is a constant, say K. Now let us find the ratio for each of the values from the table. X by Y is equal to 1 by 500 is equal to 2 by 1000 is equal to 3 by 1500 is equal to 7 by 3500 and so on. All the ratios are equivalent and their simplified form is 1 by 500. In general, X by Y is equal to 1 by 500 is equal to K, where K is a constant. When X and Y are in direct proportion, we get X by Y is equal to K or X equals to KY. K is a constant. Considering any two ratios given above, say 2 by 1000 is equal to 6 by 3000, where 2 of x1 and 6 of x2 are the number of shirts denoted as X and 1000 of y1 and 3000 of y2 are their prices denoted as Y. So when X and Y are in direct proportion, we can write x1 by y1 is equal to x2 by y2, where y1, y2 are values of y corresponding to the values x1, x2 of x. Observe the following 5 squares of different sides given in the graph sheet. The measures of the sides are recorded in the table given below. Find the corresponding perimeter and the ratios of each of these with the sides given and complete the table. X by Y where we have the X values and Y values written in the fraction form X by Y. Example: if 6 children share 24 pencils equally, then how many pencils are required for 18 children? Solution: let X be the number of pencils required for 18 children. As the number of children increases, the number of pencils also increases. Let's observe the table. Number of children, we have the given values, and number of pencils, also we have the given values. In the case of direct proportion, we take x1 by y1 is equal to x2 by y2. Now by replacing the values, 6 by 24 equals to 18 by x. Now we push x to 6 and we get it multiplied. So 6 into x by 24 is equal to 18. And we find the value of x, which is equal to 18 into 24 by 6. After cancelling, we get the value x is equal to 72. Hence, 72 pencils are required for 18 children. Unitary method. We know the concept of the unitary method studied in the previous class. First, the value of 1 unit will be found. It will be useful to find the value of the required number of units. We will try to solve more problems using the unitary method. Example. A car travels 90 km in 2 hours and 30 minutes. How much time is required to cover 210 kilometers? Solution. We know that 1 hour is equal to 60 minutes. 2 hours similarly is equal to 120 minutes. So the time taken to cover 90 km as given is equal to 2 hours 30 minutes, which is nothing but 150 minutes. Time taken to cover 1 kilometer is equal to 150 by 90 minutes. Time taken to cover 210 km is equal to 150 by 90 into 210 minutes, which is equal to 350 minutes, which is nothing but 5 hours 50 minutes. Thus, the time taken to travel 210 km is 5 hours and 50 minutes. Inverse proportion. Let us consider the following situation. The following table shows the number of workers and the number of days to finish the construction of the water tank in the school. We can see the number of workers and the number of days shown on the table. In this situation, the two quantities, namely the number of workers and the number of days, are related to each other. We observe that when the number of workers increases, the number of days to finish the job decreases. Consider the number of workers as x and the number of days as y. Then we note that the product is always the same. That is, x into y, which is equal to 2 into 40, and then 4 into 20 is equal to 5 into 16 and 10 into 8. Consider each of the values of x and the corresponding value of y. Their products are all equal, say xy is equal to 80 is equal to k. K is a constant and it can be expressed as xy is equal to k, k is a constant. If y1 and y2 are the values of y corresponding to the values of x1 and x2 of x respectively, then x1 y1 is equal to x2 y2 is equal to k, x1 y1 is equal to x2 y2. We say that x and y are in inverse proportion. Example. 60 workers can spin a bale of cotton in 7 days. In how many days will 42 workers spin it? Number of workers and number of days is being shown on the table. Solution. Let x be the required number of days. The decrease in the number of workers lead to an increase in the number of days. Therefore, both are in inverse proportion. For inverse proportion, x1 y1 is equal to x2 y2. Hence, 60 into 7 is equal to 42 into x. So, we transport x to the left hand side and transport 7 to the right hand side. So, x is equal to 60 into 7 by 42, and we cancel. 7 times 6 gives us 42, 6 times 10 gives us 60. So, the total answer for the value of 6 for the value of x is equal to 10. In 10 days, 42 workers can spin a bale of cotton. Points to remember. A change in one quantity results in a corresponding change in another quantity is called proportion. Two quantities x and y are said to be in direct proportion with each other if they increase or decrease together in such a way that x by y remains constant. Two quantities x and y are said to be in inverse proportion if an increase in x leads to a decrease in y or vice versa in such a way that the product xy remains constant. Thank you for watching.